are present after 10 seconds. So, of course, after 10 seconds is half of that. So after 10 seconds, it's going to be 40 grams. After 20 seconds, so this is after 10 seconds, because that's the half-life. After 20 seconds, it's going to be half of 40. So it's going to be 20 grams after 20 seconds. After 30 seconds, it will be half of this. And then what else they wanted? After 10, 20, 30, move away, 40 and 50. Okay, so after 40 and 2.5 after 50. So every 10 seconds, this becomes half. After 10 more seconds, this becomes half. After 10 more seconds, this becomes half. After 10 more seconds, this becomes half. Why? Because the half-life is 10 seconds. If I start at this moment, let's say I have here these 8 grams. In 10 seconds, there will be 40. 10 more seconds later, 20. 10 more seconds later, 10, 5, and 2.5. That's what the meaning of half-life is. I have 80 now. In 10 seconds, I'll have 40. If I have 40 now, in 10 more seconds, I'll have 20. That's the radioactive decay. Radioactive substances behave like that. That's why when we get a dye in our system for whatever MRI or other tests, every 10 seconds it will diminish. If it's iodine or whatever. It may be, as you saw, 7.5, 7.2 days or something else. But all those radioactive substances decrease their mass in time based on their personal half-life. Is this okay?
Yes, I was just wondering if this type of question will be on the test by any chance.
But this is way too simple.
Okay.
This is way too simple. We had way more sophisticated problems. So this is way more sophisticated than just dividing the substance, the mass by 10, by 2, half, making it half every 10 seconds. So this is a way more sophisticated type of problem. Over there, I don't have to do anything. No calculations are required other than dividing by 2. So this is basically for trying to understand how the half-life works or what it means. It's not an actual question, basically. It's just something to make sure that we understand how half-life, so what is the meaning of half-life and what does it do to the mass of radioactive substance. It's a kind of a warm-up of a question. Good? Anything else? Other questions? Anything else from your homework or anywhere? Okay, so let's pick something else.
I have one.
Yes, I'm ready. Very good. Students in a psychology class took a final examination as part of an experiment to see how much of the course content, we did this problem in class, they remembered over time. They took equivalent forms of the exam in monthly intervals. Thereafter, the average score of the group, f of t, in months. Okay, so f of t is score, and t is in months. I have to take notes on that. And they're given us the function, which is f of t equals 76 minus 15 natural log t plus 1. If you ever watch those videos from the previous classes, you will see this problem. Different function, I believe. What was the average score on the original exam? We can stop sharing so we can identify the average score, and then we'll go back to part B and so on and so forth. In part A, we are asked to find the average score that was obtained initially. What does that mean? What are we asked to find?
T of 0?
Yes. So f of 0. 0 plus 1 is 1. Natural log of 1 is 0. 0 times 15 is 0. 76 minus 0 is 76. No, it's not percentage score. Sorry. Good. So let's see part B. I'm pretty sure it's the exact same problem we did in class. Okay. Good. Very good. Part B. In part B, they're asking us to, what was the average score after 8 months? So what are we asked to do now? And then sketch the graph using a utility, graphing utility, describe what the graph indicates in terms of the materials retained by the students. Good. So they want us to determine after 8 months and then graph it. So what are we asked to find?
So now for T, do we plug in 8?
Yes,
Is that what that
exactly.
means?
That's exactly what it means, is the T is in months. So after 8 months. Good. So of course, you know what I'm going to do. I'm not going to calculate one by one. I'm going to put in y equals. I'm going to enter 76 minus natural log of x plus 1 and close. And there is a 15, sorry, there is a 15 in front of it. Insert 15. Good. So then the second end table. If you have any doubts, you can plug in 0. We have to get 76 for sure. And then I have to plug in 8. And we get 43.0. So 43%, 43 score, average score. Good. So now when I want to graph this function, because they want us to use a utility, obviously 0 to 12 is the viewing window for x. Now, y minimum, I don't know, but y maximum cannot be more than 80. Okay? And y minimum, I'm going to consider it 0. And with a scale of 20. So 0 months to 12 months with a scale of 2. 0 for knowledge till 80, because the maximum score is 76, with a scale of 20. So now I'm going to graph. And we graph that, if you remember, we have the same graph. So obviously starts at 76 right here, when x is 0, y is 76. And 2, 4, 6, 8, as you see right here, it's 43. And then it continues to decrease. So what is our conclusion? If our average score was 76 initially, and then it starts dropping. After 8 months, it was 43. And after 12 months, I can find the number very easily, 37.5. So it drops from 76 to 37.5 in 12 months. And also we can see that in the graph. Good. Any questions on this problem? Okay, so let's continue with the next one. Anything else? And you may have questions on any problem you need help with, anything. Anything? Anybody, please? Nobody needs any help with any problem? Everything is perfect? Christy, do you have anything else?
No, I don't have anything else.
Okay, Emily, do you have anything else?
I may have some more work from my homework. I can take a look.
Yes, please.
Just give me a few seconds.
Of course. Hunter, do you have anything else in the meantime for us?
No, not currently.
Okay. Imani, do you have anything for us? Anything you need help with?
No, I don't.
Okay. Is there any particular topic you would like to go back to? From all the topics we listed.
Can we work on some more exponential functions?
Of course, we're ready. Yes.
I don't have any. Do you have any from the book?
Yeah, of course. I think I closed the book. When you say exponential functions, you are talking about graphs, we're talking about equations.
The equations.
The equations, they are in 4.3. Let me look at the page. 4.4, sorry. 4.4, page 517. Okay. So from 1 through 48. These are the exponential equations.
Can we start with 45?
Yes, of course. 45. Yes, we just did a similar problem a second ago with this one. So the trick here is to realize that if we denote this, let's say by t, this happens to be t squared. Because if you square e to 2x squared, you get e to 2x times 2, which is this. So then the equation is t squared plus 5t minus 24 equals 0. So it is easy to factor. If you have difficulties with that, you use the apps and the polynomial root finder feature. But this is t plus 8 and t minus 3. T squared minus 3t plus 8t. 8t minus 3t is this. And 8 times negative 3, negative 24. So then we have that t equals negative 8 and t equals 3. No restrictions. This is a nice equation. It's not log, it's exponential. No domain, nothing, nothing, nothing. Everything works. But now this is an equation that gives e to 2x equals negative 8, and this one e to 2x equals 3. How come? Because t is e to 2x. So therefore, this equation is e to 2x equals negative 8, and this equation is e to 2x equals 3. However, e to 2x is always a positive number. So e to 2x can never be a negative number, unless there is a minus in front or something else. But the way the equation is, you will not be able to solve this because it has no solutions. You cannot apply natural log because you cannot apply natural log to negative 8. So this has no solutions. The other one does. Because e to 2x equals 3, of course, we are going to apply natural log to both sides. We bring down 2x, and natural log e is 1. So 2x equals natural log 3, and I have to divide by 2. And this happens to be the only solution. This one has no solutions. Don't ever try to apply natural log to 0 or to negative numbers. The calculator will scream, "Have you lost your mind?" This is what the calculator would like to say. So if you apply natural log, let's say to negative 8, it will scream at me because it's not possible. Also, because e to 2x one side is negative 8, 2, 4, 6, 8. So let me draw it. So this is y is negative 8, and this is e to 2x. Where do these two meet? And the answer is never. This one cannot come closer to this because this is the horizontal asymptote. And it goes on to 0. And this is y equals negative 8. So this side is always positive, and this side is always negative. No positive can equal a negative. So e to 2x cannot go below y equals 0, and this will always be y equals negative 8. These two will never meet. So there are no solutions. E to 2x can never equal negative 8. Good. Good. Anything else? When it comes to exponential equations. Or any other topic.
15.
Yeah, which one?
15.
15. Let's look at 15. 15 is always an easy situation. And it's always an easy situation as long as we can present both sides with the same base. So 6 raised to x minus 3 over 4 equals 6 to 1/2. Two exponential notations with the same base equal to each other, these two have to be the same. Otherwise, they will never be equal. So x minus 3 over 4 must equal 1/2. And as we know, this is a proportion. This times 2 quantity x minus 3 must equal 4 times 1. I will prefer dividing both sides by 2 and then adding 3 to both sides. And you can always check. How do I check this particular situation? Be very careful how you enter it in the graphing calculator though. So we have, so it's better just simply do it without the calculator. So it's 5 minus 3 is 2. 2 over 4 is 1/2, and this is power 1/2. There is nothing I need to do. So 5 minus 3 is 2. 2 over 4 is 1/2. This is 1/2. This is power 1/2. So x equals 5 is correct.